So let's see how we express a vector in component form. So let's say that we have a vector A that has magnitude of 20 meters and has a direction of north 30 degrees west. All right, so first let's draw it. Let's see how it looks like. So usually what I do is I draw the compass direction, the north. Therefore, that's the east, south, and west, south, and east. And our vector is roughly, so it's north going 30 degrees toward west. All right, so this one here is 30 degrees. So this is vector A. So what does it mean to find components? It means find two vectors along the y. And remember, earlier we talked about y and x-axis. To find components means to find two vectors along the y and x-axis so that vector A is actually the vector sum of these two. What is so special about AX and AY? AX is perpendicular to AY. All right. How do we do that? Well, we draw a right angle triangle with hypotenuse our vector, and this is AY. This one here is AX. So let's find the component. So now it turns into a right angle triangle problem, which we are very comfortable to work with. All right. So we have this right angle triangle. Remember, this is AX, this is AY, and this is just vector A, and this is the angle, 30 degrees in general theta. So what do? We say, well, AX is equal to its opposite. So it's hypotenuse times the sine of the angle theta, and AY is, again, hypotenuse, but AY in this case is adjacent, cosine of the angle theta. All right, so that's how we find the components. However, in our case here, as you can notice, the vector is on the second quadrant. Recall the quadrant, right? This is the first, this is the second, this is the third, and this is the fourth quadrant. And recall that all the points in the first quadrant have positive coordinates. On the second, have negative and positive. On the third are both negative, and on the fourth are positive and negative. All right. So which means that the x component for our example the x component AX is negative and AY is positive. So let's actually go ahead and do our vector. So AX, the components will be a negative 20 sine 30 and AY, which is meters, and AY is positive 20 cosine of 30 degrees, again, meters. All right, this happens to be roughly negative 10 meters, and this is square root of 3 over 2, 1.7 times 10^17 meters. And that's how you find the components for a given vector. All right, this is the general approach. And actually, to be fair, I'm going to put here that these are plus or minus depending on which quadrant the vector will land on. All right, So next, we're going to do the opposite. If we have the components, we are going to find the actual vector.